Welcome to the Salmon Runs YouTube. Enjoy the video.
You begin by assembling parts and mapping pins so hardware and code speak the same language. First, mount the servo and connect its signal to a PWM-capable pin. Make sure ground is shared with the Arduino. Then wire the keypad and RFID per their pinouts and attach a stable 5V supply. Once done, upload a minimal sketch that defines pins, initializes serial and libraries, and runs a simple servo sweep to verify motion. This step proves wiring and basic code work before adding logic. Next, you implement the access logic and secure credentials so the lock behaves reliably. Write handlers for keypad and RFID input with debounce and validation, and design a simple state machine: locked, authenticating, unlocked, and timeout. Store authorized ID and hashed PINs in EEPROM so they survive power cycles. Make sure to limit retries and enforce a cooldown to deter brute force. Also add LED or buzzer feedback tied to states. Once these pieces work in sketch form, integrate them with your physical lock actuation routine. Finally, you finalize mounting and run comprehensive tests to ensure reliability and safety. Secure the servo or bolt actuator to the door mechanism, route cables through strain relief, and enclose electronics to prevent tampering. Make sure ventilation prevents overheating. Test full open/close cycles, low power or battery failover, and your user onboarding flow. If something fails, power and grounding issues are most common. Check for a common ground, verify 5V and servo current, and enable temporary serial logs to find logic errors. Then remove debug output for production.
Thanks for watching. Consider subscribing if we helped you.